Question 1. A project manager is reviewing the quality metrics for a new software release. The team has been tracking the number of defects found during user acceptance testing, UAT. Which of the following quality tools would be most effective for illustrating the trend of defects over time and identifying if the process is stable? A. Pareto chart. B. Histogram. C. Control chart. D. Scatter diagram. Answer: C. Control chart. A control chart is the most effective quality tool for illustrating data trends over time and determining if a process is in control or stable, based on established upper and lower control limits. This chart visually represents process variations, distinguishing between common causes, expected variation, and special causes, unexpected, assignable variation, that indicate an out-of-control process needing investigation. For instance, if the number of defects consistently falls above the upper control limit, it signals an unstable process that requires immediate attention and root cause analysis. Always remember that control charts are about monitoring process stability and predicting future performance. Question 2. During the manage quality process, a project team conducts a quality audit. Which of the following is the primary purpose of performing a quality audit? A. To identify deliverables that require rework or repair. B. To determine the overall quality of the project's final product. C. To identify inefficient and ineffective policies, processes, and procedures used in the project. D. To inspect each completed deliverable for compliance with specifications. Answer: C. To identify inefficient and ineffective policies, processes, and procedures used in the project. The primary purpose of a quality audit, conducted during the manage quality process, also known as quality assurance, is to evaluate whether project activities comply with organizational and project policies, processes, and procedures. This evaluation aims to identify practices that are inefficient or ineffective, recommend improvements, and ensure adherence to quality standards. For example, an audit might reveal that a particular review process consistently misses defects, suggesting a need for procedural improvement rather than just finding product defects. Audits focus on the how of the project, not just the what of the product. Question 3. A project manager is defining how quality requirements and standards will be met throughout the project and for its deliverables. Which project document is primarily concerned with this activity? A. Requirements Management Plan. B. Quality Management Plan. C. Scope Management Plan. D. Risk Management Plan. Answer: B. Quality Management Plan. The Quality Management Plan is the project document that describes how the project management team will implement the performing organization's quality policy and is primarily concerned with defining how quality requirements and standards will be met. It outlines the specific quality activities, procedures, and responsibilities for ensuring the project and its deliverables meet the defined quality objectives. For instance, it might specify that all critical software modules must undergo peer review and unit testing before integration. This plan is crucial because it sets the framework for all quality-related efforts, ensuring that quality is embedded into the project's processes from the start. Question 4. A project team is analyzing process problems by categorizing potential causes into categories like people, process, equipment, environment, and materials. Which quality tool are they most likely using? A. Pareto chart. B. Control chart. C. Histogram. D. Ishikawa diagram. Answer: D. Ishikawa diagram. An Ishikawa diagram, also known as a fishbone diagram or cause and effect diagram, is a quality tool used to identify and categorize the potential causes of a problem or an effect. It visually structures brainstormed causes into main categories, often the 6Ms: manpower, methods, materials, machines, Mother Nature/environment, measurement, helping to trace problems back to their root. For example, if a team faces frequent software bugs, they might use this diagram to explore causes related to inadequate training, people, faulty testing procedures, process, or outdated development tools, equipment. This tool is excellent for structured brainstorming to find the underlying issues. Question 5. A project manager wants to ensure that the project's processes are continuously improving and that the team learns from past mistakes. Which of the following quality management philosophies or methodologies emphasizes this concept? A. Total quality management, TQM. B. Statistical process control, SPC. C. Design for X, DFX. D. Acceptance sampling. Answer: A. Total quality management, TQM. Total quality management, TQM, is a holistic organizational management philosophy that focuses on continuous improvement of processes, products, and services to achieve customer satisfaction. It emphasizes the entire organization's commitment to quality and continuous learning from past experiences, making it a cornerstone for sustained improvement. For instance, a TQM approach might involve regular team retrospectives and process adjustments based on feedback, fostering an environment where lessons learned are actively applied to refine future work. TQM isn't just about controlling defects, it's about embedding quality into every aspect of an organization's culture and operations for long-term success. Question 6. The project team has completed a deliverable and is now performing inspections to ensure it meets the specified requirements. This activity is part of which project management process group? A. Planning process group. B. Executing process group. C. Monitoring and controlling process group. D. Closing process group. Answer: C. Monitoring and controlling process group. Performing inspections to ensure a deliverable meets specified requirements is a key activity within the control quality process, which falls under the monitoring and controlling process group. In this stage, deliverables are verified for correctness against the defined quality standards and specifications. For example, if a software module is completed, the team would conduct thorough testing and reviews to ensure it functions as intended and meets all design criteria. This process is crucial for preventing errors from propagating and ensuring that only validated deliverables move forward to the next stage or to the customer. Question 7. A project manager is working on an Agile project and needs to ensure that quality is built into the product from the start rather than just inspected at the end. Which Agile practice directly supports this principle? A. Extensive documentation. B. Dedicated quality assurance team. C. Whole team responsibility for quality. D. Formal change control board. Answer: C. Whole team responsibility for quality. In Agile projects, quality is integrated into every iteration and is a shared responsibility of the entire team, not just a separate quality assurance department. This approach fosters a mindset where developers, testers, and other team members collectively work to build quality in from the very beginning through practices like test-driven development, continuous integration, and frequent reviews. For example, instead of a separate QA team at the end, Agile teams often pair program and perform early testing to catch defects immediately. This emphasizes a proactive stance on quality, ensuring it's an ongoing effort rather than a final gate. Question 8. A project manager is reviewing quality metrics and identifies a process that has been producing defects at an unacceptably high rate. The project manager decides to invest in training for the team and implement new tools to improve the process. This investment is an example of what type of quality cost? A. Internal failure cost. B. External failure cost. C. Appraisal cost. D. Prevention cost. Answer: D. Prevention cost. Prevention costs are incurred to keep errors out of the process and prevent defects from occurring in the first place, rather than finding them after they have happened. Investing in training and new tools to improve a process and reduce defect rates is a classic example of a prevention cost. For instance, training developers in secure coding practices or purchasing automated testing software are proactive measures to enhance quality. These costs are typically more effective and less expensive than dealing with defects once they have occurred, emphasizing the principle of quality built-in. Question 9. During project execution, a project manager discovers that some recently acquired materials do not meet the specified quality standards, leading to potential rework. To identify the root cause of this issue and prevent its recurrence, which tool would be most appropriate? A. Scatter diagram. B. Pareto chart. C. Root cause analysis, RCA. D. Histogram. Answer: C. Root cause analysis, RCA. Root cause analysis, RCA, is a highly effective problem-solving technique used to determine the underlying reasons for a defect, problem, or nonconformance, rather than just addressing its symptoms. When materials don't meet quality standards, RCA helps delve into why, perhaps due to a flawed procurement process, inadequate supplier vetting, or incorrect specification. For example, an RCA might reveal that the purchasing department didn't use the approved vendor list, leading to substandard material acquisition. By identifying and addressing the true root cause, the project can implement corrective actions to prevent similar issues in the future, fostering continuous process improvement. Question 10. A project manager wants to visually represent the sequence of steps and decision points in a process, especially to identify bottlenecks or areas for improvement. Which quality management tool should be used? A. Control chart. B. Flowchart. C. Histogram. D. Scatter diagram. Answer: B. Flowchart. A flowchart, also known as a process map, is a visual diagram that displays the sequence of steps and decision points in a process. It is an excellent tool for understanding how a process works, identifying potential bottlenecks, waste, or areas where quality issues might arise. For instance, a flowchart for a software deployment process might show delays at a specific approval step, indicating a bottleneck. By mapping out the process, teams can gain clarity, streamline operations, and identify opportunities for efficiency and quality improvements. Question 11. In an iterative and incremental development environment, the concept of done is crucial for quality. When is a feature or increment considered done in Agile projects? A. When all code is written. B. When it passes unit tests. C. When it meets the team's definition of done and is potentially shippable. D. When the product owner accepts it. Answer: C. When it meets the team's definition of done and is potentially shippable. In Agile projects, the definition of done, DoD, is a crucial quality concept that defines the checklist of all criteria that a product increment must satisfy to be considered complete and ready for potential delivery. This isn't just about writing code or passing unit tests, it encompasses testing, integration, documentation, and adherence to quality standards, making the increment potentially shippable. For example, a DoD might include code reviewed, all tests passed, integrated, and user acceptance criteria met. This shared understanding ensures that every increment is a high-quality, usable product, promoting continuous quality delivery. Question 12. A project team is analyzing the frequency of different types of defects found in a new product and wants to prioritize them based on their impact. Which quality tool would be most effective for this purpose? A. Control chart. B. Histogram. C. Pareto chart. D. Scatter diagram. Answer: C. Pareto chart. A Pareto chart is a specialized type of bar chart that displays the frequency of defects or problems in descending order of their occurrence, combined with a line graph showing the cumulative percentage. This tool is based on the Pareto principle, 80-20 rule, suggesting that a small number of causes account for the majority of problems, making it highly effective for prioritizing issues based on their impact. For example, it might show that 80% of software bugs originate from 20% of the code modules. This helps teams focus their efforts on the most impactful issues first, maximizing problem-solving efficiency. Question 13. Which of the following is an example of an internal failure cost within the cost of quality framework? A. Cost of product testing and inspection. B. Cost of customer support for warranty claims. C. Cost of scrap and rework due to defects found before delivery to the customer. D. Cost of quality training for employees. Answer: C. Cost of scrap and rework due to defects found before delivery to the customer. Internal failure costs are expenses incurred to fix defects found before the product or service is delivered to the customer. These costs arise when quality failures occur within the project's internal processes. For example, if a manufactured component fails a quality check on the production line and must be scrapped or reworked, the associated expenses, like material waste and labor for rework, are internal failure costs. These costs highlight the inefficiency of having defects internally in contrast with external failure costs, which occur after delivery to the customer. Question 14. A project manager is reviewing quality control measurements and notices a series of data points on a control chart that are all within the control limits but consistently fall below the mean. What does this pattern indicate? A. The process is out of control and requires immediate adjustment. B. The process is stable and performing as expected. C. The process is likely experiencing a non-random pattern or shift. D. The process is improving significantly and exceeding expectations. Answer: C. The process is likely experiencing a non-random pattern or shift. Even if all data points fall within the control limits on a control chart, a consistent pattern, such as several consecutive points above or below the mean, or run, indicates a non-random behavior or a shift in the process. While not strictly out of control, by exceeding limits, such patterns suggest an assignable cause is influencing the process and should be investigated. For example, if all recent bug reports consistently show fewer bugs than average, it might mean the reporting mechanism has changed, not necessarily that quality dramatically improved. Monitoring for these patterns helps in proactive process adjustment before actual control limits are breached. Question 15. The project team has delivered a component, and a quality inspector is now verifying that it meets the technical specifications and standards previously defined. This activity is best described as A. Quality assurance. B. Quality planning. C. Quality control. D. Quality improvement. Answer: C. Quality control. Quality control, often referred to as controlling quality, involves monitoring specific project results to determine whether they comply with relevant quality standards and identifying ways to eliminate causes of unsatisfactory performance. When a quality inspector verifies a component against technical specifications, they are performing an act of quality control, inspecting the actual deliverable. For instance, if a software module is tested against user requirements and performance benchmarks, that testing is a quality control activity. This process focuses on the outputs of the project to ensure they are correct and fit for purpose. Question 16. A project manager is conducting a meeting to define the quality standards relevant to the project and identify how to satisfy them. This activity is part of which project quality management process? A. Manage quality. B. Control quality. C. Plan quality management. D. Implement quality assurance. Answer: C. Plan quality management. The plan quality management process is where the project manager and team identify quality requirements and standards for the project and its deliverables, and document how the project will demonstrate compliance. This is a foundational planning activity that sets the stage for all subsequent quality efforts. For instance, deciding to adhere to ISO 9001 standards or specific industry benchmarks for product reliability happens during this planning phase. It defines the what and how of quality for the project, ensuring a clear roadmap for achieving quality objectives. Question 17. Which of the following best describes the principle of design for X, DFX? A. A method for identifying and prioritizing process improvements. B. A systematic approach to design a product for a specific aspect, such as usability, manufacturability, or cost. C. A technique for analyzing project data to identify trends and variances. D. A process for ensuring project activities comply with organizational and project policies. Answer: B. A systematic approach to design a product for a specific aspect, such as usability, manufacturability, or cost. Design for X, DFX, is a set of guidelines and considerations used in product design that aim to optimize a product for a specific outcome or attribute, represented by X. This X can stand for various aspects like usability, design for usability, manufacturability, design for manufacturability, cost, design for cost, or reliability, design for reliability. For example, design for assembly involves designing components to be easily assembled, reducing production time and errors. This proactive approach integrates quality considerations into the design phase, significantly reducing potential problems downstream in the project lifecycle. Question 18. A project team is using statistical sampling to test a large batch of manufactured components. They decide to inspect only a predefined percentage of the batch to infer the quality of the entire batch. This approach is A. A form of 100% inspection, reducing the risk of defects. B. An efficient method for controlling quality when destroying items during testing. C. More costly than inspecting every item in the batch. D. Not reliable for making inferences about the whole batch. Answer: B. An efficient method for controlling quality when destroying items during testing. Statistical sampling is a method of selecting a subset of a population for inspection or testing to make inferences about the entire population, especially useful when testing is destructive or impractical for every item. For example, if testing a car's airbag involves its deployment, you can't test every airbag. Statistical sampling provides a cost-effective and efficient way to assess quality while managing resource constraints. It's an efficient method of controlling quality when 100% inspection is unfeasible or destructive, providing a reasonable level of confidence without checking every single item. Question 19. A key output of the control quality process is verified deliverables. What happens to these verified deliverables next in the project lifecycle? A. They are immediately shipped to the customer. B. They are used as input to the validate scope process. C. They are archived as part of project closing. D. They are used as input to the direct and manage project work process. Answer: B. They are used as input to the validate scope process. Verified deliverables are outputs of the control quality process, signifying that they have been checked for correctness and compliance with quality requirements. These verified deliverables then become key inputs to the validate scope process. In validate scope, the verified deliverables are formally accepted by the customer or sponsor. For example, once a software module is verified by the quality control team, it is then presented to the end users or customer for their formal acceptance. This two-step process ensures both internal quality compliance and external stakeholder acceptance. Question 20. A project manager on an Agile project is facilitating a retrospective at the end of a sprint. The team identifies that recurring bugs are slowing down their progress. What is the primary purpose of discussing quality issues in a retrospective? A. To assign blame for the defects to specific team members. B. To update the risk register with new quality-related risks. C. To identify process improvements to prevent similar issues in future sprints. D. To determine if the project is still aligned with the business case. Answer: C. To identify process improvements to prevent similar issues in future sprints. In Agile methodologies, retrospectives are dedicated meetings held at the end of each iteration, sprint, primarily to inspect the team's process and identify ways to improve it for the next sprint. When quality issues like recurring bugs are discussed, the goal is not to assign blame but to collaboratively determine the root causes within the process and identify actionable improvements to prevent their recurrence. For example, the team might decide to adopt pair programming or increase automated test coverage to address bug recurrence. This continuous improvement mindset is central to Agile quality management. Question 21. A project team is regularly conducting internal reviews and audits of its processes and standards to ensure they are being followed. This activity is specifically part of which project quality management process? A. Plan quality management. B. Manage quality. C. Control quality. D. Perform quality audits. Answer: B. Manage quality. The manage quality process, formerly known as perform quality assurance, focuses on translating the quality management plan into executable quality activities that incorporate the organization's quality policies. This includes performing activities like quality audits and process analysis to evaluate whether the project processes are being executed correctly and are effective. For instance, conducting internal reviews of coding standards or testing procedures to ensure compliance falls under manage quality. Its primary goal is to ensure the effectiveness of the processes that produce the project deliverables, aiming for continuous process improvement. Question 22. Which of the following inputs is crucial for the plan quality management process to ensure that the project's quality requirements align with stakeholder expectations and regulatory needs? A. Work performance data. B. Organizational process assets. C. Requirements documentation. D. Verified deliverables. Answer: C. Requirements documentation. Requirements documentation is a crucial input to the plan quality management process because it details the stakeholder needs, expectations, and desired product features, which directly translate into quality requirements. To define how quality will be managed, the project manager needs to understand what the project is supposed to deliver and to what standards. For example, if requirements specify a system must handle 1,000 transactions per second, this directly informs the quality plan regarding performance testing. Without clear requirements, it's impossible to establish meaningful quality objectives or metrics for the project. Question 23. A project manager is focusing on preventing defects rather than inspecting for them. Which of the following concepts aligns with this proactive approach to quality? A. Attribute sampling. B. Cost of conformance. C. Prevention over inspection. D. Tolerances over control limits. Answer: C. Prevention over inspection. The principle of prevention over inspection emphasizes designing quality into the process from the outset, rather than trying to find and fix defects after they've occurred. This proactive approach aims to prevent errors and defects before they are introduced into the product or service. For example, implementing robust design reviews and thorough training to prevent errors is an example of prevention, which is generally more cost-effective than extensive final product inspections. This core quality management principle highlights the value of building quality in, rather than trying to inspect it in. Question 24. A project manager is concerned about the cost of quality. Which category within the cost of quality, COQ, framework represents the expenses incurred from defects found by the customer after delivery? A. Prevention costs. B. Appraisal costs. C. Internal failure costs. D. External failure costs. Answer: D. External failure costs. External failure costs are the expenses associated with defects that are found after the product or service has been delivered to the customer. These costs can include warranty repairs, customer support, product recalls, liability claims, and lost reputation. For instance, if a software bug is discovered by a customer after deployment, the cost of providing a patch or support for that issue falls under external failure costs, which are typically the most damaging and expensive type of quality cost. Understanding these costs helps projects prioritize investment in prevention and appraisal. Question 25. A project team is developing a new mobile application and has established specific metrics for response time and crash frequency. These metrics are part of which quality management output? A. Quality management plan. B. Quality metrics. C. Quality checklist. D. Process improvement plan. Answer: B. Quality metrics. Quality metrics are specific measures used to quantify the degree to which a deliverable or process meets specified quality requirements. They provide objective, quantifiable data to track and assess quality performance. Establishing metrics like response time, example, login screen must load within 2 seconds, or crash frequency, example, no more than 0.01% of sessions result in a crash, means defining what will be measured and how. These metrics, once defined, become key indicators that the project team uses to monitor and control quality throughout the project lifecycle.